Hey, it's Mr. Barr, and these are the notes for scaled area. And scaled area is actually a really useful thing. When people draw out plans for a house or for a garden, they don't draw it full size. They draw it on a piece of paper, and everything is like shrunk down. So on a drawing, 1/2 of an inch equals 2 feet in real life. So that's the idea of scale. So what would 2.5 inches be in feet? So there's our first problem. So the idea of scale so let's go with our name. And our title is scaled area. So if 1/4 of an inch equals 2 feet, what is 2.5 inches? So I think there are a couple of ways of visualizing this, but let's just take this up to an inch. If 1/4 inch is 2 feet, then what's a full inch? Or we can look at it like this. So if 1/4 equals 2 feet, 1/2 equals 4 feet, right? 1/4 plus 1/4, 2 plus 2, okay? Well, 1/2 plus 1/2, so a whole would equal 8 feet. So I'm just kind of scaling it up. Well then, let's see, if 1 inch is 8 feet, 2 inches would be 16 feet, and 1/2 an inch, right? So I've got an inch, I have a 1 inch plus a 1 inch plus an 8 inch. Well, that's an 8 plus an 8 plus a 4, isn't it? Which gives us 20 feet. So that's one way to think about it. How did I do it on my notes? So what I did here is I actually broke it up into inches on my notes, or on my paper. I can think of it like this. This is 2 inches, 2.5 inches. So this would be 1 inch, 2 inches, 3 inches. And I know that each inch here, this is actually, there are the fourths. There are the fourths. And there are the fourths. I'm just drawing it out like it's a ruler. Basically what I'm doing is this. I'm basically making a ruler on my paper. And I know that 1/4 is 2 feet, so 2 feet, 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 2 feet. It takes me to right here. And what is that? That's 20 feet. So a couple of different ways of thinking about it. Total is 20 feet. Let's try it again. You do not have to do this one in your notes, but there will be more notes coming. 1/2 an inch is 5 feet, 7 inches. Okay, well, if 1/2 an inch, then a full inch equals 10 feet, right? And now I've got 7 full inches, so it's 7 times 10, which is 70. Now we're going to apply it to area. If each square is 2.5 feet, what is the area? Each square is 2.5 feet. Okay, so what's this distance right here? What's this? Well, that's 2.5 feet. And what's this? Well, that's 2.5 feet also. So what's the entire thing? Well, this is 5 feet, isn't it? And what's this? Well, this is 2.5, 2.5, 2.5. So what's that? 7.5. And what's this right here? This is 2.5, 2.5. Well, that's 5 feet again. So I'm converting everything before I find the area. Now I'm ready to find the area though, aren't I? Let's see, what's this? This is 5 times 7.5, which is 37.5. And this thing's kind of symmetrical, so I know this is also 37.5. And what's this? 1, 2, 3. This is 7.5. 1, 2, 3, 4, 5, 6, 7 times 2.5. So this is 2.5 times 7. 17.5. This is 17.5. So 7.5 times 17.5 gives me 131.25. And I add up all those numbers and it gives me the total area. Which in this case would be, I'll add them up. I have it as 206.25. Okay, let's find the area of this strange shape. Before I start, I want to convert the scale from inches into feet. So 1 inch equals what? A quarter of an inch is 2.5 feet. So 1 inch equals 10 feet, right? A quarter plus a quarter plus a quarter plus a quarter. 2.5 plus 2.5 plus 2.5. Okay, so 1 inch equals 10 feet. This is 10 feet. Well, what's 3/4 of an inch? See, that's a fourth plus a fourth plus a fourth. Well, that's 2.5 plus 2.5 plus 2.5, 7.5. All right, so now I have the real numbers. What I have here is half a circle with a radius of 5. This is half a circle with a radius of 5, right? Not a full circle, half a circle, half pi radius squared. That's the area of my, not volume, area. There's the area of my circle. This is just, what is this? This is a rectangle that's 7.5 by 10. And this is a triangle that's 7.5 by 1, so 1/2, base, which is 1, height, which is 7.5. There's my triangle. There's my triangle. There's my rectangle. There's my circle. I add them all together, and I have the combined scaled area. So our notes today are not that crazy. We're going to add one thing to it. And it's going to be this: convert the scale first and then find the area. And on these notes right here, I want you to draw a happy face. And there's a good chance that when I'm checking notes, I'll be looking for those happy faces to know that you watched the entire video. Thanks for watching.